This is an interview with Jay Alammar. Jay has a technical blog as well as a YouTube channel where he explains a lot of technical AI-related stuff, like his attention and transformers blog that you definitely have heard before. And he has amazing learning resources. Now, he is focused on building LLM University with Cohere, and we will talk about that in this episode. But not only. We will also dive into the different challenges in building large language model-based apps and how to build them. I think this episode is perfect for anyone interested into large language models, but mainly for people that want to create a cool app using them. I hope you enjoy this episode.
So I'm Jay. I worked as a software engineer. I've been fascinated with machine learning for so long, but I really started working in it just about 8 years ago when I started a blog to document how I'm learning about machine learning. It seemed to be this power that gives software capabilities to do that's quite mind-blowing if you know what the limitations of software are. And you see these machine learning demos coming and doing things that really stretch the imagination in terms of what is possible to do with software. So that's when I started my blog, which a bunch of people have seen use for, because I started with introductions to machine learning and just in general how to think about propagation and neural networks. And then I moved into more advanced topics covering attention and how language processing is done and language generation. And then it really exploded when I started sort of talking about transformer models and BERT models and GPT models. From the blog, I got to work with Udacity, creating some of their nano degrees for educating people on how to use these language models and how to train them. These were two things that really launched a little bit of how I work with machine learning and AI. The blog I've seen has had upward of 6 million page views so far. A lot of it around transformers and how they work. And yeah, I think maybe tens of thousands of people have went through the various Udacity programs on machine learning, deep learning, NLP, computer vision. And most recently, I get to work very closely with these models with Cohere as director and engineering fellow, where I continue to learn about the capabilities of these models and explain them to people in terms of how to deploy them in real-world applications. So how can you build something with them that solves a real problem that you have right now? And that includes education, it includes talks, that includes creating schematics, but also like crystallizing a lot of the lessons learned in the industry of how to deploy these models and how to build things around them. Cohere. So a lot of people have heard about transformers, and Cohere was built by 3 co-founders, some of whom were co-authors of the original Transformers paper, and they've been building these transformers in the cloud, these hosted, managed large language models for about 2 or maybe 2.5 years now. I've been with the company for 2 years and I've seen this deployment and rollout. And yeah, since then the company has trained and deployed, 2 families of massive language models that do text generation, but also text understanding. And we can go deeper into these 2 capabilities of large language models.
Absolutely. And you mentioned that you started 8 years ago, your blog. And of course, as with most people, I discovered you through just the amazing blog that you wrote on transformer and attention. And it really helped me and lots of people. But since you started so long ago, what made you start and made you get into the field? Because 8 years ago, AI hype wasn't really near what it is right now. So how did you discover it? And what made you create this blog about it?
Amazing. Yes. So I had working as a software engineer for a long time. Sometimes I would come across some demos that to me feel magical. And a lot of them come from machine learning. And so it's on YouTube. If you Google word lens, this was a demo that came out in 2010 of an iPhone 4 that you can point it to, let's say, a sentence written in Spanish, and it will transform that into, let's say, the English translation. It will superimpose it. And right now it's 13 years later now, but that still feels like magic, especially if you like know about software and how complex dealing with language and images. To be able to do that without a server on software that's running on a machine, that felt like an alien artifact to me. And so seeing something like that, I've always had this to-do list in my head of get into machine learning, find the first opportunity to get into machine learning and understand, because it's clearly going to be transformative into software. The moment that really gave me the jump into it is around 2015 when TensorFlow was open sourced. It felt like, okay, this is the time now. They're open source code. So because, a lot of these things, you have to be very close to a research lab, or you work sort of deep inside a company. And at the time, I'm like an outsider. I wasn't in Silicon Valley, wasn't in sort of, a big tech hub. I was just a software person with a laptop with access to the internet and just trying to learn on my own without sort of a group or a company or a research group around me. Wasn't, let's say, an academic. And so a lot of it was like self-learning. So when TensorFlow came out, I was like, okay, I read a paper in 2004 called MapReduce, and that launched the big data industry. So everything sort of around big data is a massive industry. And it felt like, okay, the launch of TensorFlow is like, and everything that started happening in deep learning we're in the beginning of this new wave of deep learning. And so, I started to take some tutorials. But then how do you feel satisfied if you spend 3-4 months learning about something? Yes, you have more information. You've developed a little bit of a skill. But like, I always need an artifact that sort of solidifies that from month 1 to month 3, I have this thing. And that's what the blog was for me. It's like, okay, I struggle very hard to understand a concept. Once I understand it, I'm like, okay, there's a better, maybe an easier way for me to have understood it if it was explained this way. And that's how I try to sort of let me chew on this. Once I understand it, try to sort of hide the complexity. The things that made me intimidated when I was like, I would learn something and then I'm faced with a wall of formulas, for example, or like a lot of code. Before getting the intuition, that made me feel intimidated. And sort of those feelings are sort of what guides me to have these gentle approaches to these topics to the readers, where we hide the complexity. Let's get to the intuition. Let's get a visual sense of the intuition. But it happens over a lot of iteration. And I'm happy to get into like how the writing and visualization process develops over time with me.
Yeah, I'd love to, because mainly I do the same thing with YouTube, where I actually started when learning artificial intelligence just to force myself to study more and learn more, but also just like you, I wanted some kind of result or output from what I was learning, and just to confirm that I actually correctly learned things. Because if you can explain it, it should mean that you understand it. And so I perfectly understand you, and I'm on the same page. But another way is also to like create something or code something or develop an application or whatever. So what made you go the path of trying to teach what you were learning instead of using or learning something to create something else?
So because it's always like as you develop a skill, you're not always building that skill to build one product that you have. You're learning and you're observing and you're seeing what is popular in the market. And then as you develop your skills, maybe in month 6, you're still not able to, train a massive model, deploy it to solve a problem. And so like I decouple launching a product from the learning and acquiring the skill. And that's why writing is a really great middle ground or artifact of learning, because it's also a gift to people. And it comes from like gratefulness, like feeling grateful to the great explainers that explained things to me in the past. So when I would, really struggle in the beginning to understand, what neural networks are, and I come across a blog post by Andrej Karpathy or by Andrew Trask or Chris Olah that explain something visually in a beautiful way, or in like 11 lines of code where you can feel that you have it, like I feel a lot of gratefulness that this made me closer to a goal that I have
Yeah.
by Simplify It. It's what we're trying to do with what we just released, like LLM University at Cohere. And a lot of my learning journey is sort of echoed by it. I'm happy to see sort of that work of education, learning, growing as a community, teaching each other, but also collaborating on how we sort of learn, and is something that I think benefits everybody. And I advise everybody to write what they learn. A lot of people are stopped by, no, I'm just a newbie, I'm just learning this. But a lot of the times, just you listing the resources that you found useful is valuable on its own, let alone sort of how much it will brand you, that you sort of wrote something. And the writing process, to me, helps me learn so much deeper. Let's say the illustrated transform of the blog post. So there's, maybe 20 visuals on there. The visuals you see on the blog post, each one is, let's say, version number 6 or 7. Like I iterate over it so much more and learn in the process. So I would read the paper. I would say, okay, do I understand it correctly? This is my understanding of it. And then I would read another paragraph and say, no, the way I said it, this sort of contradicts with it. Let me draw it again with this new understanding. And then once I know that I'm going to publish it, I'm like, a part of my brain says, wait, other people are going to read this. How sure am I that this is how it actually is? Maybe I should actually go and read the code to verify my understanding here. Like this depth of investigation, I would not have done it if I just read the paper and said, okay, I understand it. And then there's another thing of like, and it's a good life hack that I sort of hand out to people. So if you're explaining somebody's paper, the paper has their emails and you're helping them sort of spread their ideas. So once you work on it, have it in a good shape, write something, send it to them, have some feedback from them. That is also sort of another really great source of feedback and connections that I've had over the blog. And it really helps remove some of the blind spots that you sort of cannot see. This is especially more important and valuable for people who are, again, not in Silicon Valley. The majority of people are, somewhere in the world without access to, the most the people who are working much closer with this technology. So a lot of us, all we have is the internet. So how can we sort of learn with online communities? That's another thing that we sort of, LLMU helps to democratize that knowledge, but also Cohere has a community-driven research arm called Cohere for AI that aims to broaden machine learning knowledge and research, and sort of accepting people from, I think people from over 100 countries right now. So to me, that touches a little bit on it, because coming into that, I was like, I'm a professional working in a specific profession. I'm really excited about this. I want to learn this, but I'm nowhere near any of these, very big companies that do it. How do I do it? And so that's what I hope, the opportunities that people get from sharing, creating things, sharing what they learn, and learning together as a community. And it's what we try to do also in, let's say, the Cohere Discord. We're like, write, let us know, let's learn together as a community.
Yeah, it's definitely super valuable to share anything you want to share. And if you are wrong, well, in the worst case, I believe nobody will see it, just because it's like not high quality. But if people see it, you will end up being corrected, and you will just learn even more as well. As long as you are not like intentionally spreading misinformation, it's possible that you are not completely sure that you fully understand what you are trying to explain, but it can still be just like doubts in your head, and you are still right, and you can share. It's like a fear you have to get over at some point.
100%. That stops a lot of people. A lot of people are like, I'm not the world's best expert on this, and you don't have to be. And like, you can write that right in. You're like, and to me, that gave me a lot of license and a lot of comfort in writing the things where I say, I'm learning this. Let's learn it together. These are my notes. This is how I understand it. And once I do that, I learn deeper. And, people correct it. I just update it. I just put an update, or, change the visual, and that's a great way of learning together. So you're doing your audience sort of a favor by learning together. So, and it helps you career-wise. So I advise a lot of people to say, okay, this will help open doors for your career and, for possible jobs that you can have in the future by showing that you're passionate about this one topic, or later on, if you do it long enough, that you're an expert in it.
Absolutely. Yeah, visibility is super important. Even when you are learning, like by being on YouTube for 3 years, I've seen a lot of people asking me like what to learn, where to start, and etc. And especially when learning online, a lot of people get stuck into like doing one course and another, and they just keep on trying to learn because they just like myself and most PhD students, we almost always have the imposter syndrome, and we think we are not the expert, and it's people should not trust us or believe in us. But it's just like we need to get over that and just try at least.
Yeah, 100%.
And stay transparent.
Yeah, but like even if you go to the world's best experts on anything, the experts usually are the experts on one very narrow thing. And then they're just learning everything else. They're not just So it's these are just our limitations as humans.
And right now, with all the experience that you have teaching it, like with your amazing blog, as I said, on transformer attention and everything related to large language models, and now with the LLM University, where you also try to, as we spoke with Louis in the previous episode, you also do your best to explain how they work and what you can do with them. And I know that this usually requires lots of visuals are very helpful to try to teach how complicated things work. But I wonder if after all this time working with this and trying to explain it, you could find a way to explain transformers and attention relatively clearly now with just the audio format. Would you be able to explain how it works to, for example, someone just getting into the field?
Okay. Yeah, we have really good content on LLMU for that. And one thing that makes LLMU special is that I'm collaborating on it with incredible people. So Luis is easily one of the best ML explainers and educators in the world. And right now, if somebody wants to learn transformers, I really don't refer them to the illustrated transformer that I wrote. I refer them to Luis's article on an LLMU on transformers, because in the illustrated transformer, that there was a context where I was expecting people to have read the previous article about attention and RNNs. And if you're coming in right now, maybe you should skip learning about RNNs and LSTMs. You can just come right into neural networks and then sort of transformers and attention. And so part of what makes LLMU special for me is collaborating with Luis on it, but also with Mior Amr, who's like one of the best visual explainers of things. Mior has a visual intro to a book called The Visual Intro to Deep Learning that has visual explanations of a lot of the concepts in deep learning. And one of the best people who can really take a concept and put a visual picture on it. So that collaboration has been sort of a dream come true for me on LLMU. So the question on how I've been explaining transformers to very different audiences over the last 5 years, and there are different ideas, yes, depending on who the audience is. So one way is to say, right now a lot of people are used to generative models, to generative transformers, and so that's a good way to see, okay, how does a text generation model, one of these GPT models, how does that answer a question if you ask it? And the way it does it is by generating one word at a time. And so that's how it runs on inference. How does it generate one word at a time? We give it the inputs. Let's say we say, what date is it today? It breaks that down into, I'll say words. The real word for it is tokens, but let's say it breaks it down into the words, and it feeds it into the model, and the model, on the other side of the model comes the next word that the model sort of expects. And then that is added back to the input, and then the model generates a next word, and then a next word, and then a next word. this is how it works. This is how these text generation models work now if you give them input. That doesn't answer everything. How are they able to do this? What happens under the hood that makes them do that? That's another thing. But in the beginning, I like to give people a sense of, okay, when you're dealing with it at inference time, this is what it's doing. You can then go into the actual components. So how does it do that? Well, the input words are translated into numeric representations. Computers are computers, they compute. And language models are technically, I heard this from somebody called Sam Joseph. Transformer language models are language calculators. So everything has to become numbers, and then those numbers through calculations and multiplications become other language. And so that's what happened inside this box, which is the model, which was trained. We'll get to how training happens at the end, but now just assume we have this magically trained model. You give words, it predicts the next word, and it gives you something coherent based on the statistics of the text that it was trained on. Mechanically, how it works is that the input text goes through the various layers of the model. And the model has, let's say, components or blocks. This can be 6 layers or in the original transformer, but like, you know, some of the large models now are 90 or, 100 layers. And each layer processes the text a little bit, outputs numerical representations that are a little bit more processed, and that goes to the next layer, to the next layer. And then by the end, you get enough processing that the model is confident that, okay, the next word is this word. So this is another layer of, let's say, breaking it down. And from here, we can take it into different ways. We can say how it was trained. And then we can also break down these blocks and these layers and talk about their various components. So I will have you choose your destiny and sort of steer me which way would you like us to go next.
I think I'd rather go for how the blocks are made, what the blocks are made of, and how it works.
Amazing. So I give an example of, there are 2 major capabilities that correspond to the 2 major components of what's called a transformer block. Have you seen the film The Shawshank Redemption?
I haven't.
It's a very popular film, but like it's just these 2 words that are commonly used together, Shawshank and redemption. So if you tell a model Shawshank, it will, just based on a lot of the data that it was trained on, then there aren't a lot of words that appear in the training data set that usually come after Shawshank. So the highest probability word would be redemption. So just based on what the model has seen in the past.
Yeah.
And so that is the job of one of the 2 components. That's what's called a feed-forward neural network. That's one of the 2 major components of this transformer block that just works on these, let's say, statistics of. So if you only have that component of the transformer block, then the model can make this prediction. If you give it an input text of saying Shawshank, it will output redemption. That can work. But then language is a little bit complex. And that is not the only mechanism that can make software generate. You need another mechanism, which is called attention. And attention, we can think about it as saying, okay, what if we tell the model this sentence and try to have it complete? The chicken did not cross the road because it... Now, does it refer to the road or to the chicken? It's very difficult to say, okay, to rely on the words that usually, traditionally, statistically appear after the word it, because that will be a meaningless sentence in a lot of cases. You need to bake the understanding of, are we talking about the street or are we talking about the chicken? And that's the goal or the purpose of the second layer, the attention mechanism. How does it do that? So it's built in a specific way that we don't need to go into sort of how it's, but that's its goal. And it learns this from a lot of the data that it was trained on, which we can go into sort of next. But these are the 2 major components of a model. Is a transformer model, including a GPT model. The T in GPT is transformer, is multiple transformer blocks. Each transformer block is self-attention, the attention layer, and then the feed-forward neural network. And each one of them has this goal. And then once you stack them for a model that is large enough and train it on large enough data set, you can start to have these models that generate code, that can summarize, that can write copywriting, and you can build these new industries of AI writing assistants on top of them.
Yeah, that perfectly makes sense. It's a really good explanation, and I've struggled for a while, even like I think it's 3 years ago that GPT-3 came out, and it was, I don't know why, but I think it's always the case for new technologies, but it was really hard to understand well enough to explain it properly. And well, now you definitely mastered it, and I love how you separated the different topics and not dive into the details too much. I often get stuck into the details because I like how attention calculates the attention for each word and etc. And I really like the details that you didn't even mention. And I think it's relatively important to not mention them as you've done. And yeah, I still need to learn how to best explain things, but it's really nice to see you explain something that I even know now, but it still like teaches me new stuff. It's really cool.
It helps to do a lot of iteration and just do it over and over again and explain it to people, and then notice that I said this, and then their eyes sort of started defocusing a little bit and sort of going back to say, okay, maybe this was a little bit too much detail. Let me delay it. You can still mention the details, but I love to layer it of, like, say, you get one part of the concept and then you go a little bit deeper into another part, and then but you get the full concept first at a high level, and then a little bit of a more resolution on another part. That's a little bit of a philosophy that I've seen work over the years.
And I think just for a regular presentation, it's also a good format to follow, that just even to mention it, that like that's the broad overview. I will dive into the details later, but for now, just focus on that. Like, I think just mentioning this made it like more interesting. Like you are a bit lost, but you know that it's gonna come, and so like you don't feel lost. I think it's a better way of explaining, for sure. Even if, for example, anyone listening that are not teachers or do not have blogs, but still need, for example, they are working and they need to present something, or any kind of presentation, or just sharing knowledge, is just really relevant to learn or improve how you share it. Now everyone talks about ChatGPT, and so I would love if you could go over the different steps from the self-supervised part to the fine-tuning to the reinforcement learning with human feedback. Like, how would you explain all those quite complicated steps in simple words?
Yeah, so I do intend to at some point write something about human preference training, either with RL or without it. There are different sorts of methods. So training works. One of the things that makes these models work now is that we can have a lot of data that is unlabeled and train the model on. So we can just get free text from the internet, from Wikipedia, for example, or books, or from any data set, and we can use that to create training examples in this unsupervised, which is now called semi-supervised way of saying, okay, let's take the one page from Wikipedia, maybe a page about the film The Matrix, for example, or Shawshank, or just any article, and say, okay, that page has 10,000 words. Let's create a few training examples. Let's take the first 3 words and present them to the model and have the model try to predict the 4th word. That's a training example. And then we can then again have another example where we give it the first 4 words and have it try to predict the 5th word. And so you can see that we can just slide this window and create millions or billions of training examples. And that's what happens in the beginning. This is why they're called language models. This is a task in NLP called language modeling. Now, that turned out to be one of the most magical things, one of the biggest returns of investments that maybe the technology ecosystem or like human technology has ever given us back. That with this, you can go so far. And in ways that sort of are really surprising to the people who are working closely with this technology. That if you do this with large enough models on large enough data, the model then will be able to retain information, world information. So you can ask it about people and it will tell you, who acted in the matrix and what date and what time, and that information starts being there. It starts to generate very coherent text that sounds correct and is grammatically correct. And how does it do that without us writing all the grammar rules in it? If you train it large enough on a multilingual data set, it starts to being able to do that in all languages, in multiple languages. So the language modeling is one of the magical things that sort of are really bringing this massive sort of explosion in capability of software and AI. And it's the source of where all of this starts. And it's the first step in training these large language models, and it's the one that takes the most compute and the most data. So this can take months and months to train. To take a model in machine learning, you take a model and then you can start with a model with with any number of parameters, but they're random in the beginning, and the predictions that the model makes are junk because they're random. But it learns from each training step. When we give it the 3 words and have it predict the 4th word, its prediction is going to be wrong. We'll say, no, you said this. This is the correct answer. Let's update you so the next time you see this, you have a little bit of a better chance of doing it again. This step is what happens millions or billions of times. This is the training. This is the learning in machine learning of making a prediction, updating the model based on how wrong that prediction was, and doing it over and over again. So that is the first and most expensive step in creating a baseline model. Once that came out and people started using it, you can make it do useful things, but you have to do a lot of prompt engineering to have the model. Because you can ask the model a question and say, how do apples taste? And the model, based on just what it's seen in the data set, it can ask another question and say, how do oranges taste? And how do strawberries taste? These are all reasonable continuations because you gave it a question, gave you more questions, but maybe changing the fruit type. But the people from their interactions actually wanted was, if I ask you a question, give me an answer. If I give you a command and tell you to write an article about apples, I want you to write an article, not to give me more commands about this. And so this is what's called preference training. And to do that, you get these training examples of a question and its answer, or a command and where you say, okay, write me an article about X, and then you have the article about X, and then you train the model on this data set. And that's how you get that behavior of the model that follows what people started expecting from the model of follow my. And so that's what commands are. That's what Cohere's command model is tuned to do, and that's what Instruct GPT sort of started doing, and how it improved on GPT-3 in the past. So that sort of next step, and then you can get a little bit more. You can align the model better to those behaviors by having another sort of training step, which sometimes can include reinforcement learning, by not just doing language modeling on this new data set that you've created and provided, but also giving it good examples and bad examples, and to say, okay, make it closer to good examples and farther from bad examples as rated by another, let's say, reward model. But that complexity, I think a lot of people don't need to get into. Like, as long as you understand the language modeling objective, and then the idea of preference, that gets you most of the understanding that you need. Then just focus on how can it be relevant and useful for your own product that you're trying to build. What kinds of prompts, what kinds of pipelines or chains that are useful for that. And that's, for the vast majority of people, much better than sort of understanding the Bellman equations or the detailed reinforcement learning steps.
Regarding the different products that you build with those models. I know that you talk a lot about that in the LLMU, and one thing that is, I believe, super important and promising, other than, for example, fine-tuning and the common models, is to use embeddings and build applications on them, like memory retrieval related applications or any other kind of semantic search classification, and etc. And I wonder, first, I have two questions with that. And the first one is, what are embeddings and what can you do with them? But also, what to you is more promising behind trying to make the perfect ChatGPT model with lots of fine-tuning and like the best comments possible and human feedback and everything to make it perfect, or like use a model just for embeddings and then to work with very specific applications like those, or they are just very different use cases and both are relevant?
Yeah. So there are going to be people who use both. There are going to be people who are just going to be, using different prompts and sending them to a large model and getting the results back. And you see a lot of these on LinkedIn. These are the top 10 prompts to use. There's a class of people that will find that useful. But there's another class which I sort of advocate for, is how to think of these tools as components that you can build more and more advanced and let's say systems, where you're not just consuming this one service or one model, but you're actually building them as a builder yourself.
Yeah.
So I advocate for that. And for you to do that, the idea of embeddings is one of the most powerful ones and one of the most really central ideas, that just like how API is as a word is not only a technical term now, it is a business term. CEOs have to know what an API is, the last 10, 15 years. Embeddings, I believe, is going to be one of those things, because it's one of these central components of how you can deal with large language models and build more and more systems. Embeddings, in short, are these numeric representations of text. They can be of words, so things like word2vec were methods to give each word a series of numbers that represent it and capture its meaning. But then from words, we can also go into text embeddings, which is you have a list of numbers that represent an entire text or sentence or email or book, so to speak. And so that concept is very important. If you elect to be a builder with LLMs, and you start to sort of get a sense of what embeddings are, one of the best things that I advise people to build is something involving semantic search, where you get a data set. So maybe, let's say, the Matrix film Wikipedia page, break it down into sentences, embed each sentence, and then you can create, let's say, a simple search engine on this data set. And the search engine works like this. You give it a query. Let's say, when was the Matrix filmed, for example, or when was it released? That text is also embedded. So you send that to an embedding model, kind of like Cohere's embed endpoint. You get the numbers back, and then you can do a simple nearest neighbor search. That's also a very simple, like 2 lines of code. You can get this nearest neighbor, and then that will give you the top 3 or top 5 sentences that are most close to that query. The beautiful thing here is that you can, regardless of the words that you use, the LLMs capture the meaning. So even if you don't use the same words, the model captures the intent. That's why when these models were rolled out, like especially the BERT model in 2019, like 6 months later, Google rolled it out into Google Search and called it one of the biggest leaps forward in the history of search. Just that addition of that one model. And most likely, so semantic search has these 2 capabilities that you can build it on. What we just compared is it's called dense retrieval, which is you embed your archive, you embed your query, and you get the nearest neighbors. So that's one major concept that I advise people to build with. And the other one is called re-rank. And re-ranking is just using an LLM to change the order of search results that happened in a step before. So you throw your search at your existing search engine, you get the top 10 results, and you throw those at the re-ranker that sort of changes the order. And that dramatically improves. Like if you have an existing search system, this dramatically improves the quality of those search results. And so these two components each has, let's say, their own endpoint and super high quality models on the Cohere side are maybe the two best ways to start dealing with large language models, because then that is the future of generation as well. Because retrieval augmented generation is absolutely one of the most exciting areas, and one of the areas that can help you rely on information that you can serve to the model when you need it. You can update that data whenever you need it. You can give different users access to different data sets. You're not reliant on data stored in the model. You want to update them? Okay, let's train the model for another 9 months. And then, the model can sort of also, that increases the model's hallucination. There's a lot of excitement in this area that brings together semantic search and generation, and we think it's highly warranted to pay attention to it.
Yeah, retrieval is definitely, as you mentioned, a great way to not avoid but limit the hallucination problem, because you can almost it doesn't work all the time, but you can try to force it to only answer with like the response and give reference to what it responds. So like when it search in its memory and just finds nearest neighbor, you can ask it to only answer with what it find and also give the source of what it found. So that's really powerful compared to ChatGPT that will just give you text and hopefully it's true and you don't even know where it comes from. So it's definitely safer and also, as you said, easier to build. You don't require to retrain the whole model and everything, and can build multiple applications super easily. But I'm not that familiar with the re-rank system. Could you give a bit more details on how it works and how it actually reorders the answers and improves the results?
Sure, yeah. So re-rankers are these models that, let's say Google, and you're rolling out your Google search re-ranker. You have your existing system before transformers. You give it a query, it gives you 100 results.
Yeah.
The easiest way to deploy to power your search with LLMs, with large language models, is to say, okay, these 100 results, let me take the query and take each one of these results and present them to the model and have the model evaluate how relevant this result is to this text. So the re-ranker is basically a classifier that classifies. It has two parts of text. It's what's called a cross encoder. So you give it examples of a query and its answer, and it should give the result of 1, let's say, because that's a true. But then a query and a document that is not relevant to it, and the training label there is 0. So this is not relevant to this. So that's how you train it. And once you train it, you just plug it into an existing search system. The previous step can use embeddings or cannot. That's fine. But then it gives a relevance score for each of the 100 results, and then you just sort by that relevance. That becomes just one signal for your search that you can either just use and sort by the most relevant, or then you can use other signals. If you're rolling out actual search systems, you want other signals. You want, let's say, I want the more recent ones. So assign a signal for recent documents. Or if you're building search for Google Maps, you're like, okay, give me things that are closer to this one point. So that's another sort of search signal. Or you can inject, let's say, preference or things. So that's how re-rankers work. And you can sort by relevance directly, or you can just use that as one additional signal to a more complex re-ranker downstream.
Okay, much more clear now. The easiest way basically to use large language models when you already have a search system or when you have a data set, mostly. For example, anyone in a company or a manager or someone that has an issue or a problem or just in its regular work, how do they know that their problem can be helped with LLMs? Is there any tricks or tips to know that, like, oh, now I should use an LLM or something embedding or like a product of Cohere? Like, how can you know that this problem will be helped through an LLM?
Yeah, that's a great point. And the common wisdom is that, use the best tool for the job. LLMs are great for some use cases. They're not good for everything. There are a lot of use cases where somebody wants to use an LLM, and I would advise them, No, you should use a regular expression for this, or you should use Spacey for this use case, or you should use just Python string and text matching. The LLMs are just one additional tool that adds a level of capability to your system that should augment existing things that sort of work with them. So that understanding is a little bit important. Some people will be driven by the hype and would want to inject AI somehow. They told their investors we will roll out AI in our next product release. How to do that? Let's find any way to do it. No, it really should come from, let's say, user pain and what problem you're trying to solve. And you can classify two major parts there. So one is maybe you're improving a specific text processing problem right now, and you can get better results if you try an LLM. And so you have to choose what metric that you have that will improve your product or solve your pain, and then compare LLMs with existing strong baselines, which, there are a lot of things that can be done with things that are not. But then once you see that the LLM is providing that value for you, that's when you sort of progress forward. LLM providers like Cohere make it easy in terms of that you don't need to worry about deploying a model. Models are going out of memory because this model needs to fit on tens of GPUs or something. Just worry about, okay, you want to do a re-rank? Okay, send me the query, send me the 10 texts. I will send you back the ordered list, and I will make that better the next time you send me a request, because I'm updating the model or training it on new and better data every month or with every version. And so this is a new type of, let's say, providers of this technology. But yeah, definitely focus on the problem that models can. So improving existing text processing is one. That's search system classification. But there's this new capability of text generation. So AI writing systems were not possible before 3 years. So these are these new categories of so you might be wanting to innovate. I will create, I don't know, the next AI dungeon, interactive AI games, or the next media format, or I want to create a world like GTA with all of its radio stations, but all of it will be generated by the computers, and I'm going to be creating something new. And that's the second category of things you can experiment with.
It allows for a lot of new applications to be born just because before not a long time ago, but when AI first started, you needed to train your own model, and as you mentioned, host it on the cloud or anywhere, and like there's a lot to manage. But now, thanks to OpenAI, Cohere, and other companies, you can basically have someone else do that for you. But it's still there are still some challenges in building those large language model based apps. For example, if like I have a specific data set in my company, for instance, if it's a very private company and the data set cannot go outside of the intranet of the company, what can you do with that? Since Cohere and OpenAI, for example, it's all outside the intranet. So what can you do if you want to build some kind of search-based chatbot?
Yeah, that's a great question, and that's a very common concern, and we come across, like, it's one of the biggest areas that companies in the industry, but also specifically enterprise, like large companies working in regulated spaces, and Cohere actually caters to that. So there is a solution of bringing the models to your own sort of virtual private cloud. So there's this rollout with AWS SageMaker where the model can be deployed in your own cloud. The data does not necessarily go to Cohere's infrastructure. They remain on your own sort of data center, but then it's run through the SageMaker endpoint, and all of it sort of remains. And that's one of the use cases where we see a lot of demand. And sort of Cohere's focus on enterprise makes it able to focus on use cases like this, where it's like, say, not specifically consumer focused, but it's like, what are the big business problems of building the next generation of intelligent applications? And this, I like that you highlighted it, because this is commonly asked for, and we'd love to see more people sort of building with those SageMaker.
It's great to know that it's possible, and for the people that maybe have different problems, not large companies. For example, if I don't know, someone is learning and wants to build an app, what are the main challenges when it comes to building such like Cohere or OpenAI based apps where you basically use the very powerful models that already exist, but want to fine tune it or like to adapt it to your specific applications, either through a data set or just specific commands. But what are the typical challenges or things that the people that want to create cool things with those need to tackle and just go over?
Yeah. So the challenges don't all have to be technical challenges. Like everything in the past, like remains true in terms of you still need to find product market fit for your product. You need validation from your users. You need to really solve a problem and not do something that is nice to have. With the generative models specifically, like identifying reliable use cases is one thing that a lot of people need some hand holding on. Like they come across an amazing demo on Twitter or something, but then they don't realize that a lot of the demos are cherry picked. It's like they had to generate 20 generations to get that one, let's say. If you're building it as a product, it cannot work just 3 out of 10 times. It needs to work 9 out of 10 times. And so how do you get it to that level of production? That gap between a proof of concept product of this prompt can work, I will take a screenshot of it and I will put it on Twitter, to this is a reliable system behavior that I know I could put in front of my users and it will work always. Bridging that gap is one of the challenging things that a lot of people have to contend with. And there are solutions and there are playbooks, and we sort of write a lot about them and educate about. And they include things like using search, using embeddings, fine tuning is another one. The big models allow you to prototype, and they do amazing behaviors. And once you have the model able to do the behavior that you want using one example in the prompt or 5 examples in the prompt, you can then make it cheaper for you and faster by collecting that data set and fine-tuning a smaller model that is able to do that same task as validated by the larger model. That saves on context size, because you're not sending the same 5 few shot examples with every prompt. And so that is helpful. And then another part of that is, like we also talked about with semantic search and getting the relevant bits and injecting them into the prompt. Some people may think that context length will solve all the problems. If you have a very large context length, will solve. And so you will send the documentation of your software to the language model with every question that you ask about that documentation. And you can clearly see that is wasteful. If you were to answer 1,000 questions, the model has to process the same documentation thousands and thousands of times. While embeddings really is this way of caching that knowledge and retrieving the important bits. These are a couple of things that experimenting and thinking about reliable behavior is one of the learning curves that a lot of people have to go through.
What are the skills and material needed to do that? First, can only one person do that? If I want to create an app, do I need a whole team, and do I need a server? Do I need to go through a course beforehand? Like, what is the required skill set and material to get into that? Is it just impossible for one person, or can the person listening right now that has an idea can just start and learn in the process? What's accessible and how accessible is it?
So in software, like in general, you need a user interface, right? So if you're targeting users, how will they interact with it? Or are you creating, let's say, an API endpoint that other people can just connect to it? So there's a bunch of software hurdles that are not necessarily language modeling or prompt engineering or so that, let's say, piping of that information and how your users sort of connect with it. So if you know Python and the JavaScript, one person can go very, very far if they invest in sort of these two things. If you only know Python and machine learning or data science, you can create a proof of concept. You can use something like Streamlit and sort of create an application that they user interface that you can maybe demo to investors to help you build the next sort of level of it. And more you see companies like Vercel coming along and making that front end to AI pathway sort of a little bit easier. So the language models will continue to make it easier for generalists to do many things very well. We're still in the beginning of that, but it's clear that individual people who are productive will become massively more productive, aided by these technologies and what they can do. So yes, smaller groups of people will be able to do a lot more. But for now, there are these skill sets of how are you going to build the UI? How are you then going to put it in front of users? So you can roll it out on the App Store. You can do it through some marketplace. Can you do that individually? Do you know that customer segment? Do you really know the pain that you can solve with them? But a lot of people run 1 or 2 person companies where it's like, okay, charge credit cards, use these various frameworks, and then put some good-looking UI on top of it. And but then the question is, do you have enough of a competitive advantage that somebody else doesn't copy you once your service is popular? And that's another challenge of, are you building what's called enough of a moat or competitive advantage around your product that others can't just steal your idea, steal your UI, and then run with it?
Yeah, indeed. You talked about how generalists can now do more thanks to AI, and it will only increase. And that's really cool because I believe I am somewhat of a generalist. I really like to know about everything, and even though I'm doing a PhD, I'm not completely sure about like being super specialized to one thing and forget the others. Like I really like to learn everything, and that's a very recurrent topic in the podcast. It's funny how basically years ago a lot of people said that AI will increase the discrepancy between rich and poor and will just make things even more unfair than what they were. And now I believe I'm not sure if I have all the data and information, but I believe we see almost the opposite, where in my case at least, and in lots of people I know, AI actually allows people to do things that they couldn't do before, which is quite cool. It's pretty much the opposite, and it just democratizes lots of stuff, like, for example, building applications. One of my friend is currently doing some kind of challenge that she is trying to learn like to use ChatGPT, and she does something, posting daily for 30 days about ChatGPT and what she does. And she's like in human resources and she doesn't know any programming, but she still coded an application that is a to-do list and everything thanks to ChatGPT without any like Python, JavaScript, any notion of coding. And I don't know, that's incredible. It's so cool.
100%. And like I, predict that we'll start to see not one, but many 5 people companies reach $1 billion in valuation pretty soon, just aided and augmented by AI. Definitely a lot of opportunities created, but also there are a lot of challenges and that we need to be sort of cautious about. There's opportunities for misuse, as well as like the need for people to keep learning, keep developing their skill sets, use these new technologies in their own workflows to augment them and make their, what they do better and better. You can't just rely on what you learned in college when you graduated 5 years ago. The world just keeps changing very quickly. And so the more you're quick at learning and adapting and incorporating these tools in what you do, the more of the opportunity you will catch, and then you'll resist the challenges.
And speaking of these challenges, one last challenge that I often struggle with using ChatGPT or other models is hallucination. And is there any other way than, for example, using memory retrieval, or if that's the only way to solve it, but is there any other way to help improve hallucination, or just in general make those applications safer and like, as OpenAI says, more aligned with what you actually want? Yeah, there's two sides of this question. Like, obviously, you can do that during training, as OpenAI does. But what if you are using an OpenAI's product or a Cohere's product, and you want to make it safer on your end? Is there anything you can do to help mitigate the model hallucination, even if you do not control the training process?
So we already mentioned one of the big ones, which is like, actually injecting the correct information, so you're not relying on the model's parametric data.
Yeah.
That's one of them. There are methods that you, as an engineer, can build systems around. A lot of them were outlined in Google's Minerva model paper that just solves a lot of very complex mathematics using. So where we heard about things like chain of thought, where the model, you ask it a complex question, it shouldn't answer it right away. It should output the steps of how it can sort of arrive at that. Then there are there's another method called majority voting, where the model is supposed to output not just one result, but maybe 10 results. And then those 10 results, you choose which ones have occurred more than one time and use those as votes. That's specifically if you have, let's say, one specific output that you can have at the end. And so that's another sort of way. There's a paper called it around it, and the method is called majority voting. Close to this is this idea, this also recent idea of tree of thought, where it's like chain of thought, but like multiple chains of thought, and then you can sort of reduce the. So that's let's say one way of evaluating. If the model generates the answer 4 or 5 or 10 times, if it says the same thing over and over again, there's probably a good chance that it knows this. But if there's variance in what it generates from across these 5 or 10 times, that is probably an indication that the model is just being creative. And then there are things like temperature and, let's say, setting the right temperature setting that sort of augments this to a certain degree.
Yeah, it's an easy way to at least mitigate like very random answers, but still it also increases the cost since you have to generate multiple times. But yeah, it's a very easy way to do that. One last question that I have very specifically towards large language model is, the first one is, how are, for example, ChatGPT that work with many languages, how they are built and trained on many languages? Because I know there's definitely a difference between ChatGPT that works with almost every language and a model. For example, Facebook released a model that was trained specifically on French. And so it's definitely not the same thing. So what are the differences with ChatGPT? How does it work with any language that you can type in?
So multilingual models are just done by incorporating other languages in the training dataset and in optimizing the model, or let's say initializing the tokenizer, which is like a step that comes before the training the model to choose how to break down the words. But it's really just a factor of the same training process. It is language modeling, predict the next word, except in our data set, we have a lot of other languages, and that we also use to evaluate the models. How coherent is the model on this language and that language? So you use that in your incorporation. Because if you're serving these models, so if you're serving a model like Cohere's command, the one that we put out is not the only model that we've trained. No, you have to train tens or hundreds of models with a lot of different experiments to really find the best performing model and do a lot of complex evaluations. So if multilingual is one of your focus areas, which for us it is a very much a focus area, there's a lot of this incorporating it in the training data, but also in the evaluations. We have a lot of focus on multilingual on the embedding side. We have this embedding model that supports over 100 languages, which is like completely sort of geared and focused on search in the multilingual setting. So you have to pay extra attention when you're building the model to incorporate languages, because it was very easy in the beginning to just focus on English and, not consider that the vast majority of people, also speak other languages. And they need them in their day-to-day, their businesses and their usage.
So it's mainly just trained with even more data. And I believe from research, maybe you can confirm, but just like for humans, training on different languages actually improves the results in English as well.
Yes. There are things that are strange like that. Kind of like, training on code also enhances generating text with common sense or like reasoning capabilities. So the more you throw in there of like high quality data, that always seems to improve the results.
Yeah, it's just like humans when I don't remember exactly what it does to your brain, but learning a music instrument actually helps you understand other stuff better and just like makes you not more intelligent, but like it definitely helps you. It's not irrelevant to learn art or to learn a music instrument. And just with also the different languages that you basically are a different person in when you speak another language, that's also super interesting. I wonder if that's the case for large language models where they act differently in different languages, but
yeah, I mean, the distributions would be different in the different languages. And I love how also this extends to multimodal models of like, once you throw audio in there, once you throw images in there, sort of how that also could then improve language generation.
Yeah, so really exciting.
That's very interesting.
How do you see AI evolving over the next, I don't know, it's a classic question, the next 5 years, but how do you see in the next few years AI and large language models evolve? Where do you see we are going, like mostly trying to come back to specific applications with retrieval systems, or build an even better general model with less hallucination, or anything else? Where are we going?
Yeah, I mean, generation and like embedding approaches, I feel are here to stay. Things like semantic search or retrieval. Some of these are things that you can't really even do with generative models. There will be a lot of development in the models themselves. So in the quality of data that can be presented to them, and in the quantity and the types of data. So now we're at internet scale text data. Where do you go next? We talked about multimodality. That's another area where the models will improve by being able to look at images or even generate images by looking at audio or getting other sort of modalities. Beyond this, there's this idea of embodiment, so where the models can interact with environments and learn from those interactions. That will also be another sort of source of information and feedback to improve model behavior. And then there's this idea of the social interaction, how models can socially interact with large groups of people, not just one person who gives it a prompt and gets a result back. The social interactions. These are 3 of 5 world scopes that this one paper I've discussed on my YouTube channel sort of displays this future of where are we going to get more data now that we've trained on internet data. So that's on the modeling front and how to make the models better. Definitely new architectures, improvements, hardware, that will all sort of continue to develop, even though right now there's a little bit of a convergence. There haven't been any major steps on the modeling side for a while, but there's still a lot to be done in engineering. So rolling these models out, building systems around the capabilities we currently have, there's so much that can be done there that will keep so many people busy for the next 2-3 years, but also inventing other ways of using them, other media formats that are now possible. If you can generate images or generate text or full stories or full podcasts. So the world will be a little different, and a lot of people are going to be very creative in terms of what they deploy. A lot of it's going to come from the engineering side, but not only from engineering. Modeling will follow as well.
On your end, is there one thing that right now AI cannot do and you would love it to be able to do? Is there one thing that comes to your mind? Yes.
One thing that it's a little random, but it's one thing I'm really obsessed about, just the nature of learning about intelligence in software and having software solve problems in intelligent ways makes me very intrigued about other natural intelligences beyond humans. So animal intelligence, the dolphins, the octopus, the ant colony, the apes. There are efforts, like there's this project called the SETI project, CETI, for trying to throw all the NLP technology that we have on trying to decode the language and vocalizations of whales, to see, can we start to understand, maybe communicate with these other, forms of intelligent life around us that we sort of don't have yet ways of communicating to them. I'm absolutely passionate about, this language being able to allow us to connect better to other more intelligent forms of life around us.
Yeah, it's so cool. I've always been drawn into how we understand things, and just also how a cat sees the world, and just all the animals and living beings. It's really cool that like it's like neuroscience and all this is a completely, well, not completely, but it's a different field. And now lots of people come from pure software and they become interested in that, in neuroscience and these topics, just thanks to language models and how it makes you think of how things understand. It's really cool, and I'm excited to see where AI and like my field, well, our field can help the human race to understand other things. It's really cool. I have one last question for you, just because it's a topic that I'm particularly interested in. It's on your end, since you are a blogger and now even a YouTuber. First, are you using any AI help when creating educational content? Well, not necessarily LLM, but maybe AI editing or just generation or asking questions, brainstorming. Are you using any AI powered tools to make your writing process better, or just creative process better?
Sporadically, not on a, let's say, a daily basis, but yes, sometimes for like outlines or idea generation, they're useful, or like some artwork for thumbnails. Sometimes like Midjourney has been useful for some of these. But like everybody, I'm just learning how to adapt them into my workflows toward the investment.
I didn't see myself use it until very recently, and now I've seen a particular use case for me just when I'm. It's mainly because I'm French, but and not a native English speaker. But it's really helpful to help improve your formulation and syntax. That's one thing, just because it helps me improve. But another thing is I'm still currently learning lots of new stuff, and I still try to explain them while learning. And when I see a word that I don't understand, or a topic that seems a bit blurry, even if I have the paper and I think I understand them, asking GPT or any other model is quite useful. It actually like reformulates, and it can be very useful to quickly get high level understanding of specific topics. That's something I've been using recently, and it took me a while to get into that, which is weird because we are actually explaining how they work, but we don't use it nearly as much. But it's now I see a better use case. Like the more time that we have with them, the better we use them, obviously. And that's, yeah, I see it's really promising. It's really cool. But yeah, you definitely have to double check the outputs and ensure it's not hallucinating or anything else. It still requires human inputs, but it's really useful. And so just it's not really a question, but the last thing I wanted to mention, is there anything you would like to share with the audience? Do you have any projects other than the large language model university that, of course, anyone can go right now through Cohere for free, learn a lot about transformers and everything we discussed in this interview. And it's a really good resource. I definitely recommend it. But is there anything else on your end that you are excited to share about, or to release soon, or work on?
Yeah, so aside from the LLM University, we have the Cohere Discord where we answer questions. So if you have questions as you go through the LLM University, join us. Let us know what you want sort of to learn about. We're happy to sort of help you with your learning education. And then when you build something, we're also welcome that you share it and say, what problems you faced, how you solved them. So it's a community to learn together. And, we welcome everybody on the Career Discord.
That's awesome. Is there anything coming up on your YouTube or the blog?
So I've been doing a bunch of shorts. I've been digging deeper into these tools that build on top of LLMs, like LangChain, like Llama Index. So I've been doing a few of these shorts. So that's a little bit of my focus area now. But in terms of topics, if I can carve some time to talk about human feedback and RLHF, that's high on my list.
Yeah, I'd love to see that. So perfect. Well, thank you very much for all the time you gave us and the amazing insights. It was a really cool discussion to have with you. I've known you for only 2 years. Unfortunately, I didn't know your blog before that, but it's just amazing resources. And likewise for the LLMU, I'm really thankful for you and your team for building that, but also to you personally for the YouTube and the blog. It's just really cool that people like you exist. So thank you. And thank you for joining the podcast.
Thank you so much. That's so kind of you. I'm just a student like any other, and we're just learning together. Thank you so much for having me, and looking forward to interacting and speaking together in the future.